In this example, given the graph of gx, find the following limits if they exist. In part A, we find the limit of gx as x approaches 2 from the left. We position at the x equals 2, where the graph coming from the left side of the 2, the function value approaching the value -1. So the limit as x approaches 2 from the left of gx is -1. Limit of gx as x approaches 2 from the right in part B. If you go through the graph, as the graph coming as x approaches 2 from the right, the function value approaching the value 5. So the limit from the right side of the 2 is 5. In part C, the limit of gx as x approaches 2, no plus or minus sign as a superscript. So this is the two-sided limit. As part A, the left-sided limit is -1. In part B, the right-sided limit as x approaches 2 from the right is 5. These two values are not equal. Therefore, the two-sided limit does not exist. Part D, we find the function value of g at x equals 2 from the graph. The function is defined as g at 2 equals -1. For this example, in part C, the two-sided limit of the g doesn't exist, while the function g is defined as -1 at x equals 2. Part E, the limit of the g as x approaches -1. No superscript plus or minus sign, so we have to consider both sides of the graph. As x approaches -1, the left-sided limit, the function approaches the value 4, which is the same approach as x approaches -1 from the right. So the limit of the g as x approaches -1 is 4. In part F, limit gx as x approaches -4. From the left side, the function value approaching the value 3. From the right side, the function approaches -2. So the limit of the gx as x approaches -4 does not exist. In part G, limit gx as x approaches 4. From the left side, the function approaches 2. The right side approaching 2 as well. So the limit gx as x approaches 4 is 2. Part H, the g at 4. At 4, the function is not defined as you see the empty circle on the graph. So this we call undefined.